Hello, this is Scott. Welcome to my YouTube series on advanced analytics and data science. Today we're talking about process engineering, fast predictor screening of semiconductor data. So I hope you have joined me previously, but just so that you know, I cover a wide variety of platforms and I usually focus on two themes, one or the other. The first is a higher level view of the types of problems that data science can deal with, or a very specific hands-on application of a tool such as R, Statistica, Spotfire, Python, SDS, etc. So today is going to be the former. I'm going to take a high-level view of a problem that a process engineer faces, and that is screening lots of variables very quickly. And so we're going to talk about the ability to do that and the ability to scan these in seconds and then pass along the best predictors via a workflow, and the ability to work within a workflow with native operators or even open source code segments that I can drop in. And then we'll talk a little bit about the governance of the process, the ability to do all four of those things from security to version control. Okay, and then if you have any comments or suggestions, there's a couple of ways to contact me. I'm always looking forward to ways to improve. So reach out when you can. All right, so let me first go to, by the way, so I'm going to illustrate things today in a tool called Statistica. And so within Statistica, I'm going to grab a workspace and then illustrate it here. So, and then we'll come back to Enterprise and kind of wrap up at the very end. But most of my design work as a process engineer actually occurs in a design tool. And the nice thing about this design tool is the ability to create these workflows. So we're going to talk about the problem and then some of the things that you can do within these workflows. So first off, let's look at the data. So as I was saying, I'm a process engineer, and what I want to do is I want to figure out some key determinants to my process, and I have to know those in a very quick order. So what I'm going to do is I'm going to apply fast predictor screening, and I'm actually going to train up 3 candidate models, and I'm going to look at the results of those models very quickly because, again, I've got just a couple hours to do this entire process. My boss wants me to know or me to find out what, again, the most important predictors are to my outcome here in this space. So let's talk about the data that I have here. I can see up here at the top I have 527 variables and little 13,000 rows, a little over 13,000 rows. So I've got a lot ID, a wafer ID. I've got all of these different process variables, and again, there's over 500 of these process variables. And then at the very end, I'm going to scroll to the end. These are a mixture of categorical and continuous variables that affect my process, and I have a KPI. This decision variable DV1 is going to be my target, what I'm trying to predict here in this process. So I can work through these particular flows. I'm going to define a testing and a training set. And I'm going to subset that. So if you're familiar with machine learning, we build one set we partition the data into one set, which we use to train the models, and then we have another set that we use to test the models. So what I've done here is I'm just subsetting the data out, and I'm doing I think it's a 75-25 split. So 75% of my data is going into training and 25 is left for testing. So I've created that. Remember, I started out with 13,000 rows. Now I'm down to about 9,800 to test all of this up. So the key here is I'm going to use feature selection, and I'm going to specify that DV1 as my dependent or target variable, and then I'm going to select pretty much the full complement of these 500 predictors to screen through. So I can also, I have a number of different settings that I can do, but one of the things that I'm going to do is I'm going to pass downstream the top 15 best predictors. All right. So think about that. So I'm building this flow, instead of trying to train up models, and here I've got 3. Some models are very computationally intensive. So if I try to train certain models like this boosted tree or a neural net with literally hundreds upon hundreds of predictor variables, it would take a lot of time to process. Again, my boss is asking for this, ASAP. So what I'm gonna do is I'm gonna pass down the top 15 predictors and move on from there. So let's see how fast we can go through this 500 variables. And that was real time, and I'm done. So now I can see that these are the variables that are most important to that decision variable 1. So these are the variables that I'm going to pass along. Here's a visual representation of those. I can see that the top 3 very much more important than the rest of the set, and things start to move down from there. But all that to say that now I can train up my models like this shade model with that data set, as well as this boosted tree and this Mars spline, and I can build all 3 models within a matter of seconds or maybe minutes. I just ran that shade model right there that quick. The boosted tree will take a little bit longer, but actually it ran. And let me go ahead and run this Mars spline, and that was very, very quick. So so now I've built three different models, and I can look at the performance of those models. Each one of those generated PMML, which, by the way, just to show you, I have a variety of different ways to construct different code for those models. You can see here, but PMML is the way I'm going to evaluate the strength of those 3 models. I have my holdout test set. Let me look at my rapid deployment node, and I'm going to, this is a regression problem, so I'm not going to have any categorical response to play with in a confusion matrix or anything like that. But I am going to pass the predictions and the residuals downstream. So I'm going to go ahead and do that. Now I've compared all 3 different models. I've got the output for the different models. These are the estimates from those, and then the average predictive estimate of an ensemble between those 3. And then I'm going to use this model comparison node, again, because I'm in a real hurry. I'm going to let it select the best model for me. I'm going to do that by absolute mean error. And let me just run that. And then we can see here that this model comparison, the shade, the boosted tree, the Mars spline, that data is here. I'm actually using this mean absolute error and the Mars multi-adaptive regression spline actually outperform the others in that category. A little bit difference in some of these test statistics, but I can see that R squared is about 63% for that Mars spline model. So now I'm good to go. What I can do now is I can create, my boss loves visuals, and what I can do is I can bring in these predictions for these different models. I can concatenate that back to the original data set. So now I have all 535 variables, which is the original, plus I just appended these additional columns to it. I can create, all kinds of output that I want from here. Or what I could do is I could export it. I'm just showing here exporting to, say, Spotfire. You could export it to Tableau or Click or whatever. visualization tool that you have to create these into a very nice visualization that you can present. A couple other things before we break. I'm just showing you here at the very front end that I can source all kinds of information into this platform. Everything from static spreadsheets to streaming database to OSI Pi data, Hadoop, HDFS data, Excel files, relational databases like Oracle, Teradata, Microsoft SQL Server. I can annotate these things with notes along the way. There's several different ways to annotate and collaborate with the tool. And then lastly, to show you some of those governance capabilities within the platform, I have full version control. I'm not actually applying version control with this particular model, but I have the ability to create versions, and they'll automatically increment. I can compare versions within the tool as well. And then I have all of these different access permissions. It's asking me if I want to update my model, and I just did since we ran it. So you can see that engineers have different roles than other members of the group, and the permissions here for different types of the platform exist, as well as the data itself. So I can define all of that different data based upon say an engineering role or statistician role, or citizen data scientist role, or even an individual person's role. What they can see, what they can change, etc. And then let's see, a couple other things. Again, we have the version control. Also, audit logs. I didn't even mention here. We have audit log capability within these workspaces. So anyway, you get the idea, hopefully. But if you have other questions, please send me an email. I appreciate your time and look forward to doing data science again soon.